let's start our review about the last lectures. First, I will say about the diode. Last week we learned about diode and PN junctions, but actually we learned a little about the diode. Diode in circuit diagram, diode looks like this. This arrow means current's direction, and this bar means like a word. So the current can go this direction. And we finally learned about the PN junction. Junction means 결합 or 접합. And PN junction means what will happen about with the P-type and N-type semiconductors will combine. Actually, the result is looks like this. These band gap diagrams will be shown like this if N-type and P-types are connected. First, we should take a standard. The standard is a Fermi energy level because the Fermi energy level changes by the temperature, but temperature will not be changed. So if two diagrams, two types of semiconductor will combine, the band gap diagrams looks like this. And this at this point or at this part, the electrons and holes will not be there because the holes and electrons will combine and be nothing or zero. So we call this junction part, and this depletion wise. Actually, we use depletion wise or depletion parts more. And if VA will apply, what will be happen? If VA will more than 0, it means plus. We call it forward biases, and VA will less than, it means minus, reverse biases. The band gap diagram will change like this if they're plus and minus, like this red lines, and the gap will less than before. So the electrons and holes will go easier than before. And if there will be reverse biases, the band gap will be more. Junction will be more higher, so it is harder than before. The electrons go through this. And we learned about the PN junctions with math and physics. Actually, there was many equations and many physics theorems, but you should know that just this one means Poisson's equation. This equation is very, very important and is the first one and of the last one of this PN junction. This will make this band gap. You mean this one? This band gap will change like this if you 미분 or 적분 determination or something like that. The Q will be like this, and the energy will be like this, because this means the change of the plus will be like this, and the minus will be like this. Determination will be like this. And if you grad integration, it will be like this, because it's first the diode equation and the second order equations, and these two y's should be same, and this top of this triangle will be max energy. And there were many equations, but at the end of the result, the EX means this and this is the same. This means WM. This WN and this WP. At the end of the result, we have the WN and WP at the highly doped level. But I will not say about this because there are so many equations. So you should know that the Poisson equation is the most important thing in these p-n junctions with math and physics. I will end this video because I used too much times. Thanks for watching this.